So let's carry on with again, we're in squamates. We're in squamata, the lizard snake crowd. And I want to remind us of a concept that is common in tetrapods, and that's limb reduction. And we already saw it in amphibians, right, with Sicilians. And that's Amphiuma up there. Well, we see it in lizards as well. This is a lizard. This is a saurian. It's called a glass snake. And there's a bunch of species of them in North America, and there are no limbs on this thing. He's modified, adapted into a creepy crawly niche, and lost his limbs. They're just in the way. How do you know this is a lizard, by the way, when you're looking at it? If you pick this up, there's a couple ways. If you held it, it would not feel like a snake. Well, some of you have never picked up a snake. It wouldn't feel like a snake at all. Can you tell?
You say its face. It's like its cranium.
Well, certainly. I'm just saying, if you picked it up, it doesn't look like a snake, but to a lot of people who don't look closely, it does. One of the clear ways is snakes don't have eardrums, and snakes don't have eyelids. Snakes, in the strict sense, no eardrums, no eyelids. That's a legless lizard, and that's sometimes called glass snakes. And look at the genus name, Ophisaurus. That means snake lizard. They're kind of cool, and like I say, you pick one up, it feels like a lizard. Its body is rigid, and if you pick up a snake, snakes wrap and wrap up. Well, some of you haven't picked up snakes, but it just doesn't even feel like a snake. But when you modify and you adapt to that creepy crawly niche, legs are just in the way, and legs have disappeared a bunch of times in vertebrates. And look at this thing here. Snakes don't do this. Snakes don't regenerate their tail, but lizards do. That's why they're called glass snakes, because you can break them. Now here's a group that you're probably not familiar with unless you've been to like a reptile show or really interested in reptiles as a kid. They're called amphisbaenins, which is a big awkward word. Let's see if we can break that down. I need to look at it. Amphi means both or either. Not sure what that word there means. But they're also mostly legless, and they're highly adapted for burrowing. Look at the little chisel-shaped face in this guy, eye highly reduced. They spend most of the time burrowing underground. They're not very familiar to most people. And also there's only one in North America, and it's in Florida, so most of us have never seen one in the wild. There's the range there, mostly tropical or subtropical. And like I said, we got one species in Florida, Caribbean species. So this is a kind of funny one, bipes. He's got front legs, but no hind legs. They're neat. If you've ever, I had a friend who had some, and you hold them in your hand, and they're burrowing. And I've got to go back to this picture. This is the best picture. They're burrowing, and that little face is like a chisel. And you put him in your hand, and he's pushing his head, trying to get under anything he can get under. And so he's pushing his head between your fingers, and he's got a lot of strength to get under things. It's kind of an odd feeling. These are amphisbaenins, and they're just in here for completeness. It's a type of lizard, a highly specialized type of lizard. And again, most people pick that up and think, oh, that's a snake. It has no legs, and it looks like a snake, but it's a highly modified lizard.
Kind of looks like a worm.
Yeah, exactly. And some of them aren't very big. You would see it and think, oh, that's a worm. And that's what they eat. And there's the one from Florida, which is a highly specialized burrower. Eyes highly reduced, chisel-like face, no pigment. That's another thing I should think about this next time we do this. I'll try to see this. There's a thing called reptile shows. We got boat shows and gun shows. There's also reptile shows, and you go and people bring these kind of things and trade them and display them. That'd be a good field trip. Okay. This is the Gila monster. The genus is Heloderma. There's two species of this type of creature. And you know what's unique about the Gila monster in terms of lizards, if we call it a lizard? It may be a snake relative, but these two lizards do one thing that no other lizards do. They're venomous. The Gila monster is the only venomous lizard, but again, it might be a snake or a snake relative. They get about this big. You see them in the Sonoran Desert. I've seen very, very few in the wild, but I've seen them in captivity. Any zoo in Arizona is going to put one on display. They're kind of neat. They are specialists at baby birds and eggs, and so they crawl around the ground eating baby birds and bird nests and bird eggs. and they are venomous. Okay. We do have native lizards on campus. I hope you've seen them, and maybe pause a minute next time you see one and give it a closer look. This is an alligator lizard, Algaria. Oh, I don't know, with the tail, they're sometimes this big. And I see this one not extremely commonly, but they're out there. Really, really long tail. My daughter and I kept some in a terrarium. We catch them in our backyard and we keep them for a while and then turn them loose again. It makes a pretty good pet. They will readily eat crickets and things in captivity. This is the most common lizard by far you see out there. I think you guys call them blue bellies. Scalopris, it's a fence lizard. The males have blue on their flank there. You'll see them sunning themselves on rocks. Not much bigger than this with the tail. That's the most common lizard by far I see on campus. I also occasionally see something that's somewhat smaller and you might confuse for just a baby one of these, called Yuda, and you can tell them because they have big dark spots on their elbow, on their flank there, and their armpit. I also see these sitting on rocks in the morning, sunning themselves. So this is a good lizard habitat. These are 3 that I've seen.
There's a ton of those in my front yard.
Yeah. Sometimes it doesn't take much to make good habitat for wildlife, and that is wildlife. So, again, when we're looking at the squamata, lizards and snakes, there's this big division. There's one side that goes to things we traditionally call lizards. They have eardrums and eyelids, and most of them have legs. And then the other route goes here to snakes, and traditionally we thought that was 2 very separate groups. But there's some 4-legged creatures over here in the snake relative group. And so the snakes we call serpentes, and relatives. And I'm not sure what the current classification of these silly things is. So this is really a snake lizard. They're called the monitors. And it's a snake relative. And most of this, not very many of them surviving. Komodo dragon is in this crowd. That's the biggest living lizard. You're familiar? I should put some pictures of that in. That's that big thing from a Komodo island in Indonesia. It's a lizard the size of an alligator. And they're magnificent animals, and every 3 or 4 years someone gets careless and they gut a tourist and eat him. But that's these guys here. So we've always known they were weird lizards. They've always stood out from the rest of the things we traditionally call lizards. And there's a reason for that. They're really more closely related to snakes. There you go, that's a Komodo dragon. So picture that animal, but about the size of an alligator, like 2 meters long, like a dinosaur. Again, these ended up in 30s movies as dinosaurs too. They tape or glue plastic fins on his back and make him into a dinosaur. And these are they're called beaded lizards, Helodermus, the genus. There's the Gila monster from Arizona. Down in Mexico, there's a close relative down there. And there seems to be some debate on this. I don't know with the molecular techniques why they're still debating that, but these may be on the snake side of the equation, not the lizard side of the equation. I'll have to read a little bit more on that. So, but let's look at the snakes in the strict sense, and this is traditionally called the order Serpentes. And that's pretty useful to remember because serpent is another word for snake, right? I know some of you aren't fond of snakes. I'm enormously fond of snakes, and we're going to take one of our field trips and we're going to go look for some snakes. And no one has to touch one if they don't want to. No one has to get close to it if they don't want to. We're going to go down and see if we can turn a few out. We about half the time we do. We can't always, particularly late in the afternoon when our lab is they're hunkered down hiding. About 3,000 species in this order. No, pretty good size. Nice, very successful, diverse order. And again, just to emphasize, leg reduction is a thing. Limb reduction is a thing. It's just taken to extremes. This is a legless lizard, amphisbaenid, and there's a snake. So there's niches for tetrapods that don't have legs. Can you think of a mammal without legs? Highly reduced legs? Whale. I'm thinking whale of porpoise. Got front legs, not hind legs. So I think this is obvious, but it's just worth mentioning these things. When you look at a snake, you're seeing an animal with extreme specialization towards creeping and crawling. And all sorts of aspects of their anatomy has been jerked around compared to a more normal reptile to support this life mode, the creeping and crawling life mode. really primitive snakes do have remnant hind limbs, boa constrictors, and only show up in the males for some reason. But these are vestigial limbs, and there is a pelvis in there that supports them. But for the most part, snakes, no limbs at all, internally or externally. Just very primitive ones hang on to those very small legs. They're really a little more than hooks. So I mentioned this earlier, but here's how you tell a snake from a lizard. Lizards have eyelids. A lizard can close its eyes. And lizards have an external eardrum. Actually, I have an eardrum, period. Snakes don't even have eardrums. And if you get close and look, no eardrum and no eyelids. You're looking at a snake.
How do they wet their eyes?
That I don't know. I was afraid you're going to ask that. I don't think they do. I think they have a thick cornea across there. And they just don't wet it like you do yours. I'll have to look that up. Many snakes have extremely kinetic or flexible skulls. You've probably seen this egg-eating snake from India that can swallow whole eggs and then crushes it once it's inside him. And if you look at the jaws of a snake skeleton, the different bones are tied together with ligaments, not fused together bone to bone. There's a lot of flexibility there. After a snake eats, you'll see this. Not an egg eating, but a normal snake, if you feed one, they'll do this thing where they open their mouth and they'll flex the right side of the jaw, then the left side of the jaw on the bottom. They'll flex all four sides of their jaw separately to get them all back into place.
Can't they unhinge their jaws?
Yeah, some of them can. Some of them, that's not a firm hinge. That can, like this guy here, he's unhinged that, and then he has to kind of jockey it back into place. I can't think of any snake that's not a carnivore. That specialization, they're eating high quality food. They just don't have the room in their body for a plant digester as part of the thinking behind that. But I can't think of any herbivorous snake. I don't think there are any. Hearing. They don't have an external eardrum, but they do have an inner ear. And remember that inner ear bone, the primitive amnio inner ear bone is the columella. Actually, frogs have it too. The tetrapod inner ear bone, the bone called the columella, which reaches in to the inner ear. And on an amphibian or another reptile, there's an eardrum there. Snakes don't have an external eardrum, and they do a lot of their hearing through these bones here. They lay their head's on the ground anyway, but they'll press the angle of the jaw into the ground and they will feel vibrations into their inner ear. How they're hearing, it's more feeling the ground vibrations and maybe hearing things in the air. I'm not sure how well they hear. If you yell at one, how well it hears you. I can't remember why this picture's here, just pretty snakes.
Maybe the banding patterns?
Yeah, I don't know. I can point out a couple things. Some snakes have warning coloration on them. Venomous snakes, some of them are warning or cut. Yeah.
Do all snakes coil or?
I would bet every snake I've handled coils, and those glass lizards don't. That's one of the differences. You pick up a snake,
Right.
it's coiling around you. So yeah, very, 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 very flexible. Here's a little bit of snake sensory biology. A group of snakes called pit vipers, of which rattlesnakes are a part, have a special organ right here. This is their nostril. There's the eye. You can see the eye. That's his nostril for breathing and smelling. Got a separate organ down here, and that's called the pit, and it's a heat sensor. And these snakes are feeding on small birds and mammals. They're feeding on warm-blooded things, so they are cueing in on the body warmth of that prey animal. And there's one on each side, so they I don't know, can you picture the Predator movie where he's seeing the outline? I think that's what they're doing. Reptiles in general, let me broaden this for a minute. Squamate reptiles, at least, snakes and lizards, have a well-developed Jacobson's organ. And what that is, it's a mass of olfactory tissue in the roof of the mouth. Now, listen to what I said carefully. Olfactory tissue, it's part of the sense of smell. In the roof of their mouth, they've got their normal sense of smell up here, and then there's another set of organs in the roof of the mouth. And what snakes do when they're sticking their tongue out, or lizards do when they're sticking their tongue out, they're collecting molecules. And they're bringing them into the mouth, and they press the tips of the tongue up into that opening, They press it up in Jacob's organ, and they smell the tip of their tongue. You think they're tasting the air around. They're really smelling it with that tongue. And I thought, there's a great picture here. I've got to go back to find it. He's really smelling. It's just a second. He's smelling through his nose, too. That's just a second way of smelling. So that's well developed in snakes and lizards. We'll have to look and see how more widely spread it is. Can you picture, some of you had cats. Have you ever had a cat watch a bird out the window and it drops its lower jaw and starts going? Cats have a Jacobson's organ that's exposed. They don't do it with their tongue. In the roof of a cat or a dog's mouth, there's a little passageway that leads to a second set of olfactory organs, and they're smelling through the roof of their mouth. We don't do that as primates, but other mammals do. So he's not really tasting you, he's smelling you with a second set of smells. It's called Jacobson's organ. So people are always interested in snakes. So venomous snakes, in North America, nearly all our venomous snakes are vipers. And their biology is they have a venom delivery system. And by the way, venom is injected, poison is eaten. So these are not poisonous snakes, they're venomous snakes. And what they do is they typically sense their prey. A rattlesnake will sense its prey with his pit organs. He'll find a little warm blood animal. He'll reach out and bite it. And the venom has two components. It has a poison that starts killing the animal, and it has digestive enzymes. So the animal starts getting digested after the bite. And then the animal that's bitten staggers off and dies, and then he uses his sense of smell to find a dead animal, which now might be cold. So he strikes with heat, then finds his prey with sense of smell. It's a very efficient system. And if you look at a rattlesnake, for example, you can see that venomous in North America. This doesn't work in other parts of the world. In North America, our venomous snakes have this big, broad head. They're very easy to identify. Nearly all our venomous snakes have a rattle, too. That makes it even easier. But on the sides of the head there are these venom glands that attach to these hollow fangs. Here's an example of a North American venomous snake called a copperhead. It doesn't have a rattle, but it's in the same family, and they're this really pretty purple-gray color, like dead leaves. And there's one right there. When I was doing field work in the Midwest, where these are quite common, you'd walk along a stream, and you'd just be walking along, and then you'd walk back a minute or two later, and there'd be a copperhead right there that you just stepped over without seeing them. It happened all the time. They're so cryptic.
Well, at least it didn't bite you.
Yep. Here's the deal with snake bites, by the way. The venom is expensive, and biting you is dangerous. They know that. The bite is the last resort. Their first resort is for you not to see them. Their next resort is to rattle and scare you off. And if that doesn't work, they'll flee, but if you chase them or step on them, their last resort is to lash out and bite. That's the only thing they can do after that. After they've exhausted everything else, they will bite you. But it's dangerous for them because they figure I'm going to get hurt. And the venom is really expensive to build. So actually, when they're making what's called a defensive bite, biting a big animal like you, they frequently don't inject venom because it's expensive. They don't want to waste it, and they're not going to eat you. But if you're ever bitten by a venomous snake, you just get right to the emergency room. They might have been venomated, and it's usually not fatal in humans if you get treated quickly, but it can be. And some guy down in San Diego last year found a rattlesnake, and he was doing this with it, and it bit him on the hand, and he lost 4 of his fingers. That doesn't always happen, but the venom destroyed the flesh enough they couldn't save him. So be careful around them. But as I always say, that if you don't like snakes, your response is when you see a snake on a trail, is you just back away from it. They have no interest in you. A fair number of snakes are ovoviviparous. That is to say, the eggs are laid internally, and they go through the development internally, and then babies are born live. And the rattlesnakes, our rattlesnakes are ovoviviparous. They live birth tiny little rattlesnakes. There's a rattle right there. A lot of snakes are egg layers, but many are ovoviviparous. And those are newborns. That's a sidewinder, which is a little rattlesnake, and that's a dime. And that's a little baby garter snake wrapped around someone's thumb. They're eating slugs. We've had these, and we've had snakes that I was caring for that had babies, and we'd have to go to the garden and find those little garden slugs. That's what they're eating. So there's a snake skull. That's a non-venomous snake skull. And their only way of interacting with food is through their mouth. And so the teeth are often very, very sharp, and they're recurved so that once the prey item's in the mouth, its only way is down the throat. And those teeth are amazingly sharp. If you're bitten by a non-venomous snake, you end up with little pinpricks, and each little pinprick bleeds like a drop of blood. We'll get these out in lab. I have snake skulls in lab. There's a non-venomous snake skull, and there's their tools. And snakes can't chew. They just swallow things whole and digest them as they go down. That's a non-venomous snake. I think there's a rattlesnake. So again, very sharp teeth, directing the prey down the throat, and there's those fangs. Those fangs fall down when they're not in use. If they're hollow, and the venom is injected. I haven't been bitten by a venomous snake, but when I was in grad school, I was working with a guy, one of my fellow graduate students was a rattlesnake biologist, working with endangered rattlesnake at the bottom of the Grand Canyon. He was bitten on the bottom of the Grand Canyon by a rattlesnake, and after a second bite,
Oh my.
I was bitten twice. After his second bite, his wife said, "You are switching fields. You have a son now, you're switching fields." So he moved to non-venomous snakes. This is, I couldn't find a good picture of this, but this picture makes a point. And the point I wanted to make is there's not a lot of room inside a snake. And so we see a lot of simplification of body structures in there. For example, a lot of snakes only have one lung, or one lung is much larger than the other lung. Female snakes in some species only have one ovary, the other one doesn't really develop. So there's some simplification of what goes on inside the body. There's just not a lot of room there.
Why do they have the forked tongue?
The forked, it's that Jacobson's organ. You know, it may be they're smelling that in stereo. They're collecting two samples,
Okay.
putting it there. It's the way it is. I'm not sure if there's a functional explanation. Humans and snakes. We don't like snakes. Well, I do, but a lot of people don't. I can see some of your noses get wrinkled when I say we're going snake hunting. Humans have had a long relationship with snakes, and we don't like them. And it goes, back to in some of our traditions, like Adam and Eve and the serpent in the Garden of Eden. And we don't like carnivores. I've touched on this before. Sharks we don't like. Peter and the wolf, the big bad wolf. Same thing here. And that part of that may go back to, I don't know if there's such thing as a genetic memory, but they talk about in science fiction, the proto-humans were living in trees, and snakes are predators in trees, and some of them are venomous. And so this instinctual dislike may have been embedded in our biology. We don't like bears because we used to get eaten by them, things like that. I don't know, but humans and snakes have a long history. And these are signs they put up around campus, and I can't emphasize this enough. We do have rattlesnakes on our habitat around campus. I rarely see them, and I'm on the habitats more than anyone else, but we have other snakes, and there's no reason at all to harass a snake. I don't care if it's out here in the courtyard. You can call me, I'll come get it. If it's a non-venomous snake, and everyone should be able to identify a venomous and non-venomous snake, just stay away from them. And if it's on campus, I have a snake stick in my office, I have one in my apartment, I have one in my car, and I have a snake bucket. I will come rescue snakes. And I've been called, I'll show you the one we rescued a couple of years ago. But the ground screw chop their heads off with shovels, there's no reason for that. It really pisses me off. And this pisses me off too. In less civilized parts of North America, there are things called rattlesnake roundups, and this is the one in Texas is famous. They do this every year. They send yahoos out and they catch every rattlesnake they can find, and lo and behold, guess what? Every year they do it, they're finding fewer snakes. Oh, and they can't seem to figure that out. But the yahoos get to torment them and torture them, and a few of them get bitten. And then they just chop the heads off and can the meat and make those into souvenirs you see at airports. I just think that's a horrific waste of wildlife and completely unnecessary. Rattlesnake in your front yard, okay, I can see that. But going out. But the best part of it is there's Miss Snake Charmer 2012. Anyway, each to their own, I suppose.
My goodness.
A lot of people don't like snakes, and there's this neat phenomenon with snakes called a hibernaculum, and it's where certain species hibernate. Probably all species hibernate, particularly in colder climates. Certain species hibernate in huge groups, and they'll find a cave or a crevice or something, and all the snakes from everyone's surrounding area pack into this one cave for the winter. And it's called a hibernaculum, and where these things are known, they're really, really cool, because in the fall, the snakes start moving towards this site. And they go into it at night, and they come out and sun themselves in the day. And so for a few weeks in the fall, the ground is covered with tens of thousands of snakes. And in the spring, they come out in the morning to sun themselves, and they go back at night. And there's times of the year where there's just, everywhere you look, there's snakes. And there's one in Canada, it's another field trip we should take, where there's a huge one for garter snakes. And they built this provincial park around it. And there's a visitor center, and they have walkways, so you're this far above them, and you can walk out over where they are and just enjoy this little cool piece of biology without destroying it. When I was in graduate school in Oklahoma, one of the technicians had a piece of property, a rural piece of property outside of town, and again in the spring and this fall, she would say, just walking from my front door to the mailbox, which is 30 meters, I would see 4 copperheads, which is that venomous snake. And you pick up any piece of metal or toy in the yard, and for a couple weeks either side, there's a copperhead under it. And so her property had a copperhead hibernaculum on it. We looked a little bit, we never found it, and we were kind of keeping it secret because that's the kind of thing people destroy. She wasn't going to destroy it, but that's what people do. Local diversity. We got some names that by far and away the snake I see most frequently is this one here. I grew up calling it a bull snake. In California it's called a gopher snake. It's this pretty tan, brownish snake. Big adults are more than a meter in length. You don't see them that big that often. It's a small bird mammal specialist. And I say in my life I've picked up dozens and dozens of these. When I'm out, if I see a snake, I usually pick it up. And I have never had one even open its mouth and try to bite me. This is a really popular wild snake as a pet. They just don't bite. Well, they'll bite their food, but they don't bite people. And they do really well in captivity. Not that I'm encouraging you to pull one out of the wild, but see these fairly frequently. Yeah, of anything, this is a picture I took. It's hard to take good snake pictures. There's my picture of one I saw out by the housing one day.
In all your years of snake hunting, have any of your students ever been bitten?
No. No.
Just curious.
No, you guys, we're going to be really careful with snakes. And like I said, we see snakes about every other time. I'm not guaranteeing we'll find snakes, but I hope we do. No, we'll be very, very careful. They are dangerous potentially, so I don't want to soft sell that, but a little bit of caution and we're okay. This is one of our king snakes, Lampropeltis. I see these occasionally. It's a pretty banded snake. This picture, that's my picture. That was just out behind the science building. There were 2 of them back there one day, and it was a really hot day. They didn't stay still for long before they slithered away. That animal's probably a meter long, 3 feet. Here's one I found on a hill in Tough Sineville. I stopped going up. I used to do a lot of field work on the hill behind the science building, and kids in the dorm are wrecking that hill. Every time I go up, I have to pick up trash. There's paint, there's graffiti and vandalism up there. And someone went over and killed one of my snakes. That's a snake with a smashed head on the trail. No reason for that. This is our native rattlesnake. It's all along the west coast here. It's kind of a grayish purple thing. I don't see these very often. I've actually seen more squished on the road than I've seen live ones. But it is a venomous snake and it's potentially dangerous, and they do show up on campus occasionally. There were two hatchlings in the Holland Science Building one morning. Got there, and they were crawling around the hall. They were very lost. But that's our native rattlesnake, and that's one we caught. That was out in front of the Science Building one morning in the planter. And they called the police, and someone luckily called me because I got there just as the police officer did. And we encouraged her to get into this bucket. And he clearly didn't want it. And apparently the policy is they turn them over to animal control, kills them. And so I said, I'll take it. And I took it down to the park where we're going. And that's after I let her go. That's her. That's got her tongue out saying, "Who the hell is that?" And there's the rattle. And the deal with rattlesnakes is they live on the ground, and big animals tend to step on them. So that's a warning. It's their adaptation. When a big animal is around, they make that rattle, and that's a warning. I'm on the ground. I don't want anything to do with you. Just back off. And I am dangerous. I will bite. Some non-venomous snakes will actually vibrate their tail on dry leaves and make that sound. But this one, I couldn't get to rattle. I poked and prodded it, and it never rattled. Anyway, with any luck, she's never seen another human being in her life, and no human has ever seen her. All right, so that's Lepidosaurs. We did turtles. We did Lepidosaurs. Okay? Any questions? So again, focus on the transition points. What's the defining trait? What are the synapomorphies? And then I'm kind of trying to flesh them out with some natural history and some biology and trying to link them to local things. So when you come at questions, good questions are, what defines the Lepidosaurs? What's the synapomorphy there? Or, does this suggest something about the niche of this particular radiation of animals? That's kind of, in case you haven't figured out, that's kind of the way I think about questions. And so you've got a few more, let's go a few more minutes, and then I'm going to go and see what's going on with lab. I got a bunch of lectures I want to do on dinosaurs, not a bunch, I got a day or two I want to do on dinosaurs. I haven't quite got that all fleshed out yet. So we're going to come back to these, but this is a mosasaur, which is, from the Mesozoic, a big river predator, and it's actually a lizard. It's in your bag of plastic dinosaurs, but it's not a dinosaur, it's a lizard. It's a cool aquatic lizard, kind of an alligator niche. All right, so summing up the Lepidosaurs. It means scaly lizard. It's the snakes, it's the tuataras, snakes and lizards. And snakes and lizards, those aren't quite as firm concepts as we used to think they are. But mostly smallish, right? And I look at them as their ancestor managed to survive that big extinction event that did away with dinosaurs. And their ancestor was a smallish thing. All the big things disappeared in that event. And a few smallish things squeaked through. And these are them. Let me introduce Archosaurs, and then we'll call it a day. And we're going to go see what's going on in the lab. Our last group is the Archosauria. These guys over here. So Archosaur means old lizard, ancient lizard. These are the Archosaurs. Living Archosaurs are birds and alligators, the crocodile crowd. I can call them crocodilians. Birds and crocodilians. Dinosaurs are Archosaurs. Like I said, I want to do a couple, maybe a day on dinosaurs, 3 or 4 hours on dinosaurs. So these are the Archosaurs. And here they are, living Archosaurs, way at the end here. We did turtles, we did lizards, there we go. So birds are more closely related to crocodiles than crocodiles are to the rest of the reptiles. We have defining traits. Let's look at those. Probably a good place to call Bailey a few minutes early, but let's look at these. These are the synapomorphies. There's a bunch of stuff with the skull. The orbit, that's where the eye is an upside-down triangle, an inverted triangle, at least in the primitive ones. On the lower jaw, there's a fossa or fenestra called the mandibular fenestra, an opening right there. And we asked about this earlier. There's this big opening in the skull in front of the orbit. That's the antorbital fenestra, antorbital, in front of the eye. Mandibular, on the mandible. So you look at the skull, we see these features. Yeah, you look at a bird, you're not going to see these quite as well presented, but birds are highly modified. A gizzard. Now we can confirm this in living Archosaurs, and we hypothesize it in the fossil ones. A gizzard is a very muscular section of the stomach for grinding food. Some Archosaurs swallow small. I've seen birds sometimes in a dirt road swallow rocks. Some Archosaurs will put rocks in their gizzard, and it's like a grinding mill. Did your grandma make you eat turkey gizzards? It's just muscle, but just saying gizzard doesn't make it appetizing. No one's grandma making you eat turkey gizzards?
Well, you can use them and make a nice broth.
Yeah, I know. My mom always threw them away.
My grandma always makes the broth.
Yeah. So there's the archosaurs on our evolutionary tree. We've got the birds, we've got the crocodilians, and we've got all these things that are dinosaurs in the strict use of the word dinosaur, which we're gonna narrow the use of the word dinosaur down a bit. Here's just another evolutionary tree, just to give you an idea here. It's birds, it's crocodilians, it's these things we call dinosaurs. So there you go. Yeah. Did that. So let's focus on the living ones. Crocodilians and birds. Start off with crocodilians. Again, I'll say it one more time. I'll probably say it Wednesday morning again. Alligators, crocodiles, caimans, gharials. It's that whole crowd there. The Greek word for crocodile is sucus. And so you see this root in words that apply to crocodilians, and also you see it all over the place in something that looks like a crocodile or looks like an alligator. It might have this word, like protosuchus or neosuchus or megasuchus. You see this word in a lot of biology words. Look at this cool, fancy American alligator. We are so lucky to have cool stuff like this in North America. Again, it's horrific and tragic and sad when someone loses their life, but this is such a cool ancient thing. Suchus comes from the Greek crocodile god called Sobek. Just for fun, I found out there he is right there. We've got a long history of humans and crocodiles. We'll talk about the fossil stuff later when we talk about dinosaurs, but this is an ancient Mesozoic alligator called Deinosuchus, which means terrible crocodile. Yikes. And there you go, there's a bit of scale there. That was a giant animal. Today, the diversity is much smaller, mostly much smaller animals for one thing, and not particularly large. And again, the one you're going to be most familiar with, the one you see at the zoo, is the American alligator. So, in terms of living species, only 23 species still with us, a once much broader group of organisms. And what kind of habitats you expect to find an alligator or a crocodile in when you go out looking? Marshes and wetlands and rivers and streams. All the living crocodilians are semi-aquatic. It's not the case of the fossil ones, but all the living ones, this group of animals once had a much broader niche, and as time went on and other types of animals took those niches away, these guys specialized, and the modern ones, we think of them as aquatic, but if you go back into the Mesozoic, or probably a little bit further back into the Permian, that would not be the case. They would be everywhere. So yeah, all semi-aquatic, they're all carnivorous. There are no vegetarian crocodiles. And as with a lot of things, many of them have faced huge conservation issues, particularly the ones in the tropical world. And what do you think the butterflies are doing? They're drinking his tears. They're drinking his nose mucus. They're seeking out minerals. Again, salt balance is often through tears, and that's a resource. It's a salty resource if you're looking for electrolytes. Okay. Let's call it a day here. I'm going to go play. I'm going to see what's going on in the lab, and we will finish the living stuff Wednesday morning. And I want to start maybe a day and a half on dinosaurs. All right, so I'll see you in the lab in a little while. And there's a handout on Blackboard for our lab.